we're going to see if we can do a little, we're going to talk a little bit about this is not a really long presentation, but it enabled us to, you know, give you a little bit of an insight on some of the stuff I used to deal with, you know, back when I was in the dealership and all. One of the things that we used to see, there was a guy that came one time, this is an engine performance thing, in a van. He pulled over there in a van and he says, you know, I've gone all over town trying to get this thing fixed. It's cutting up on me. I can't get it to act. I mean, I can't get anybody to fix it. I spent $750. They've changed all these parts. And he said, I was afraid if I came to the dealer, I'd spend more money, but I've decided I'm just kind of desperate to get my van fixed. And so I said, okay, well, let's walk out here and have a look at it. You know, he had already had a ticket written on it, but the crazy thing about the way that I was getting paid at that particular dealership is they would typically let me set the prices. Not on everything. You know, like some stuff it was, like if it was a set repair, but like if I went out there, like I did on this one here, I went and took the engine cover off, and I saw a wire harness scratching on a bracket. And when I saw the wire harness scratching on the bracket, I said, you know, this is going to be what your problem is, because I saw copper, you know, where, and so we fixed the wires and taped them up. It took about, you know, 7 or 8 minutes, put it back together, and he cranked it up, and he instantly knew it was fixed. I don't even remember what all the symptoms were. And he says, how much is this going to cost me? And I said, about $20. You know? And he said, I can't believe I didn't come here first, you know. So, but the long and the short of it was, you know, when it didn't take very much of my time to do it, and also I had a chance to assassinate this guy's notion that he was going to get the shaft if he went to the dealership. You see what I'm saying? And that was his whole idea. He said, I spent money at all these other shops, but if you're really, well, like I was talking to Kayla, I said, if somebody threw you a starter to put on one of those Honda cars, she'd be, hey, you know, hit me with it, you know, because you put 3 starters on Honda Accords in 2 weeks. You know, y'all helped you on that, but she helped you on that one. You know what I'm saying? She knew exactly what to do and all that. Except y'all did forget about that bracket underneath there on the one they were working on. That was second-rate amateurish. Right. But anyway, these little Bronco 2s disappeared in 1990. They were replaced by the Explorer, which was a 4-door. Looks sort of like a 4-door Bronco 2. And that one right there is like an 87 model. 89 model had some wraparound headlights and all that. In 1990, you know, that's changed. In 91, they came out with a 4-liter, and that's what they put in the Explorer to start with. And this is a 2.9 right here, which is a 4-liter is basically a Borden stroked 2.9. You know what I mean? You know, the Ranger's got a 3-liter in it, but that's a different engine. It's a Vulcan engine, but the Taurus has any exhibits for the anyway, this one here, they said it skips while driving down the road. Now that was a fairly common complaint, you know, skips while driving down the road. You heard that? You know, like these guys come in here from backwoodsy areas, you know, and I'll say, tell me what your problem is, and they'll start out with more truck. You know, M-A-H-T-R-U-U-K, that's how you spell it, more truck. Driving down the road, you know, that's how they start out every time, you know. Well, it was smooth and responsive on hard acceleration when I drove it, but when it got warm enough to drop into closed loop fuel control, and that's when you're paying attention to the oxygen sensor, right? It started to adjust the injector pulse. The tailpipe started puffing out black smoke, and I had this bucking and jumping. This is what the owner was feeling all the time. And immediately, what's the black smoke mean? Hydrocarbons, yeah, that's running rich. Too much fuel, not enough air. And we've got a plethora of things going on here that can cause that, but because of the fact that it didn't do it in open loop, like when you could force it into open loop by forward an accelerator, drops out of open loop, black smoke goes away, you let off, and as soon as it can, it wants to go back into closed loop, and so it drops back into closed loop. You're, you know, puffing out black smoke. All right, so this is the way the closed loop system works. You got your OBD1 system here, which is what this Bronco got on it. And on the OBD1 system, the engine controller is basically sending, you know, fuel commands to the engine, fuel injector, pulse width, and the oxygen sensor is analyzing that after the fact. The catalytic converter treats the gases and they go out of the pipe. That's all there is to it. Well, the OBD2, and there's a lot more to it than this, but in regard to the fuel control, it's the same deal, except you added an oxygen sensor back here to check the efficiency of the catalytic converter. And what a lot of people don't know, if this sensor right here goes belly up, and the engine controller is seeing crappy stuff going on back here, it will begin to use this one on most systems to adjust the fuel trim. So don't discount that one as being a problem, if you get what I'm saying. In other words, if it sees something it doesn't like back here, it will change the fuel trim to try to keep this bad boy happy. Because that thing's covered for 80,000 miles, or it used to be, I don't know what it is now, but anyway, that catalytic converter is an expensive it's an expensive date, and the dealer doesn't even want to pay for that if they get out of it. The rear O2 on OBD2 systems, mid-90s and up, remember, it's measuring oxygen storage capacity of the catalytic converter. Can you remember that? The rear oxygen sensor is measuring oxygen storage capacity of the catalytic converter. That's on OBD2. First time I saw that was in 94 on Thunderbirds, and going on up from there, 97, just about everybody had it except some one-ton trucks, and after that, everybody was OBD2. There's a lot more to OBD2 than that, but that's what deals with what we're talking about today. Now, one of the interesting things about vehicle interclosed loop, you're never supposed to feel it happen. If you feel it happen, something's wrong. All right, so you know, if you can punch wide open throttle and feel it drop into open loop and it takes off and feels good, then when you let off and it goes back in like I was talking about, you got issues. All right, so I was thinking about my next course of action. I could check fuel pressure. Older fuel pressure regulators failed fairly regular in those days until they started replacing them with stainless steel. And I would take the fuel pressure gauge and put on it and tap on that fuel pressure regulator, and I'd see that fuel pressure go from 40 to 100 pounds sometimes. Then I'd have to replace fuel pressure. Fuel pressure regulator is not that hard to replace, you know, it's just that little 3 screws and all that. We had a recall though back in the late 80s on some Bronco, on the ones with the 5.8s and some of the 5 liters on these pickups, because they were replacing the fuel pressure regulator with a stainless steel one that was less likely to do that. And what I did was I'd take it, I think it's a T27 Torx bit and my air ratchet, and I'd go under that thing and I'd drop them 3 screws out of there and change that thing pretty quick. Some of those 5.8 sets of doggone much plumbing, you couldn't even see that fuel pressure regulator. And one of those guys was saying, man, I hate these dadgum recalls. I got one I got to do right here. And if they go reaching up under there with that Allen wrench and fooling with that, it takes forever. And I said, I've been doing those with my air ratchet. And they said, no way. I said, yeah, my little 1/4-inch air ratchet. And they said, oh, all right, show me how to do this one. Okay, so I put it on there, reached on there, felt around, pop. There it is, right there. I can't believe this. I've done about 20 of those, and I've been fighting with every one of them. You know, they got a little self-locking crap on the threads that make it hard to go down. Anyway, here's the thing. If you think you might be able to get on it with a power tool that's going to make it easier for you, just try to get on there. If you can't get on there, you can't get on there. But you might be surprised how many times you can get that power tool on there and take something off. Putting it back on, you got to be careful because it may strip something out or something like that, so be careful putting it back on. But when you're taking it off, you know, if you go into a shop where there's money being made, you can hear air tools screaming all over the place, you know what I'm saying? So anyway, when I filled on my tester, I was more likely to be related to the relationship between the PCM and the oxygen sensor. Now this is my best buddy for 10 years. I love that thing. I never knew exactly how much it cost. I heard anything from $48,000 to $76,000, but I know when they brought it to the dealership and they unloaded it, I rolled it over because I was the one who's going to be using it, and I started using that thing. And come on in here, homie. Sit down, we're talking. All right, so I was going to use that thing, and so I started using it. When the guy showed up to train us on it, he goes, man, you've already done everything you're supposed to do. Anyway, this right here was from like 90 to like 1997 or something like that. Okay, so, or excuse me, 90 to about 2000 roughly is when this thing kind of, you know, dropped out. But anyway, so what you got here, that's what the screen looked like. It had an OS2 system on it. Body, chassis, electrical, information, OASIS, you know, you can actually get the special service reports and, you know, all that kind of stuff. It's pretty handy. And so what we did here, I plugged that thing into this VIP test connector under the hood, so that's what the OBD1 did. Now this is a later model OBD connector than the one that vehicle had on it. These 2 terminals right here are your data stream, and these other ones right here, you can see what they do. Self-test input. You ground that one, it would go into self-test, and it would start flashing your codes, a 2-digit code from your check engine light. And so I connected to the key on engine off test, pulled a 41, which was a lean exhaust. See how short those codes were back in the day? There were no hard faults. In other words, this was a memory code. Ran a key on engine running test, and I got out code 41. That's what it saw right now. Now that didn't necessarily mean the oxygen sensor was bad. Could be an O2 sensor heater circuit problem, a shorted or open signal wire, or maybe a bad oxygen sensor ground. So I figured I'd go after that first. Now, real-time graphing, no data stream. SPDS machine's got a breakout harness. And it's right down there. What we do is we put that in between the engine controller and the wire harness. And it's sort of like a breakout, box machine. And it actually is reading live data on like an oscilloscope that's built into the machine. It's really cool. The closest thing to this was that dynamic data collector that I used to have one of those here. Really pricey box. But it basically would be able to tell you all kinds of stuff you couldn't get without a meter and taking a lot of time to do it and all that kind of stuff. Breakout box is okay, and I like those, but one way or another, here we headed into this. Now look at the O2 sensor signal. Now you might notice it was lit up in yellow, and that's how I knew which one of these was the graph, see? And all right, it appeared in yellow with voltage levels on the left and a timeline across the bottom. That's a standard, scope graph. And what we had here was we had like minus 1.2 volts oxygen sensor. And I'm thinking, well, with it reading way down there, if it tries to go into closed loop and it's trying to correct that, it's going to make all kinds of black smoke puff out the pipe because we put too much fuel in there. That's just the way it is. All right, and so the 2.9 liter engine been around for a while. And I started noticing a recurrent problem with these Rangers and Bronco 2 units with automatic transmission. There's an orange ground wire that leads from powertrain control module pin 49 to the back of the passenger side cylinder head. It ought to be clamped between the dipstick tube bracket and the head. Why? Because that's actually grounding the head, which is closest to the oxygen sensor you can get. And the circuit inside the PCM depends really heavily on that ground to read the oxygen sensor signal, and some techs would forget to reconnect that ground or they put it somewhere else. Black smoke problems, we would see that. You see odd voltage. Sometimes you see 2.5 volts on the O2 line if you measured it with yourself. This is what the schematic looks like. And memorize this. There's going to be a pop test on it this afternoon. Okay, but basically, HEGO stands for heated exhaust gas oxygen sensor, right? And that's HEGO ground. See that? Right there. Now, right there is basically that ground I'm talking about, if you're looking at it. This is called a block wiring schematic. It's got everything about that particular system on there. You might notice here's your injector, there's your fuel pump relay. It tells you how it's all wired up. Now, I'm not going to tell you connectors. It's going to tell you what's powered and what's grounded, but it doesn't even give you wire colors. But you are knowing how it's wired up. You see what I'm saying? It even gives you a little pinout for all the sensor and the self-test and all this stuff. There's your AC clutch with this little clamping diode. It's a pretty cool little schematic, actually. All right, so right here is what it looks like in a wireless schematic. See, it runs all over the page. I had to paste all that together to make that happen. So let's look at this a little closer right here. The Ford 60-pin PCM connector that, came up to OBD2 had pins 20, 40, 60, 16, and 49 were grounded. Now there's 20, it's going straight to ground there. 40, 60, and there's 49. See, it's a ground right there. But 40 and 60 go straight to the battery, more or less. See what I'm saying? And then there's another one over there. 16 actually comes from the ignition module, and right there. And the ignition actually feeds a ground out from the ignition module, and that was on the mounting plate at the distributor. And I had the ignition board in here that I already took it back over the other building. But it's actually that top screw in the ignition module that grounds that. So the importance of ground, when the 3-wire oxygen sensor, which is what this Bronco had on, was replaced by a 4-wire PCM pin 49 fed a ground out to the oxygen sensor from the signal return circuits inside the PCM. So you had 4-wire. All right, you see these 4 wires. Remember this is important. One of these wires is a ground for the heater. Notice this one here, the heater is not controlled by the engine controller, it's just hardwired to ground. And you got a fuse. Fuse is powering up that heater, and this right here is a reference ground for the oxygen sensor signal. There's your signal. That's coming out this way, and this is where you're getting this, what you're supposed to see right there. All right, so what I found when I went on the visual inspection, and I didn't take a picture of it when it was there, but that ground that's at the back of the head back there, this is actually right down there. This is almost, actually this is a little higher than that. But the point is, that ground had been put right here because that's a heck of a lot easier to get to than this. And whoever put it right there thought I'd be aight. You know what I mean? But that ain't the way that is. Because there's just too many gaskets in between here and that exhaust manifold where that oxygen sensor is. and you ain't gonna have a good solid, you ain't gonna have a good reliable ground there. It's really important to put the ground back where it's supposed to go. If you put it somewhere else because it's easier to get to, you're gonna make trouble for yourself. Got it? All right. Now the 60, after I did that, after I moved the ground to where it was supposed to be, things were looking a little better. See that? Until you look at the voltages. See, the voltage was minus 0.7 right there. Actually, it was running, you know, like right down here, slightly above that, to 0.3. Now we've got something that's trying to happen here, but it still don't look like it should. See where the voltage ought to be running from way down here about 0 up here to just over 0.8. And a nice little humps I was looking for. It looked a lot better, but it still wasn't right. So what you got to do is you got to make sure when it's not right, you know, that you keep going. All right. Now this right here, you see this battery? You got body ground, and this is tied in there where it's going over here. Oxygen sensor is right here, and then you're basically going to these, and there's another ground over there that I chopped off when I made that picture. All right. This is what I found in there. Does that look good?
No.
That looks awful, doesn't it? All right. So I took these ground wires and I soldered them in there, which is what you do. You know, I actually stuck them in there with that other wire, made sure I had good clean wire in there, and I soldered it. That post, incidentally, is not made out of lead, it's made out of brass. And I went ahead and did that, and whenever I got through with that, I said, all right, I've got that out of the way. You know, the only part I've replaced is that terminal. All right, and it looked a little better, but it still threw me a lean code, and so I went ahead and replaced the oxygen sensor as a last resort, and wound up with a beautiful pattern. Look where the voltage range is, you know, about 0.8 of a volt down to, you know, about 0, and it's just switching back and forth, just absolutely gorgeous. Now once again, that's not a scan tool screen, that is live data that I was looking at. See what I mean? And that's why it's got all this high definition, because this thing's checking 1,000 times a second or something. You know, it's really good. One of the things I'll tell you too about that service-made diagnostic system, I gave the people when they first got it a lot of positive feedback about all the stuff I liked about it. And I says, this is really good. I like this machine. I think it's really cool. And they were excited about that because they wanted people to use the machine a lot and tell them how it was doing in the field. And I gave them all this positive feedback. Remember this is a life lesson. All the positive feedback I gave them, but one day I hooked it up to a machine, to a truck, and it, you know, jerked me around. Didn't tell me the truth. And I was trying to, you know, use relative compression stuff on it and all that, and it wouldn't work right. Finally, I had to unhook the machine, fix it the old-fashioned way. Well, I sent them another electronic dealer service report, and I told them, I love this machine, but it cost me a bunch of work today. And I really didn't appreciate that. So I put the log file with the vehicle and all that, and because of all my previous positive feedback, I got 2 personal visits from Ford engineers and 6 phone calls. And they asked me, how can we compensate you for the time you lost? Right? I said, well, because of the way I get paid, you really need to compensate the dealership, because they were the ones that lost their fanny, you know. Because I mean, I wasn't working on commission then, but anyway, they didn't give anybody anything. But I found out later there was another guy that they gave a pickup to drive for a year, you know, for a similar situation and all that. Of course, I wouldn't want him to give me a pickup to drive for a year, because I'd be attached to the doggone thing at the end of the year. Won't let go of it, you know. Primary job of the rear O2 sensor is to do what? Write it down. That's the question. What did I say? I told you guys earlier and said, pay attention, remember this. You better get this question right. It's the biggest pencil I've seen in here lately. Y'all weren't really paying attention, were you? You didn't think you was going to have to answer that question, did you? That's why when I stop and say, you better pay attention to this, you better remember what the rear O2 sensor is for. All right, let's go. Again, name the function of the 4 wires on a conventional O2 sensor. You don't have to get them in the right order, just tell me what they do. The function of the 4 wires on a conventional O2 sensor. And I'm not talking about one of the air fuel sensors. It's got all the other wires to it. Those are the ones you learn about in electude, and it shows you how they work and all that. Did y'all have me tuned out when I was telling you, remember this, remember this, remember this, remember this? That was supposed to be a flag that was going to be on the test, right? You remember, Noah? One of the things you got to admire about Noah is he never quits. He just keeps on going. Hey there, I know it. He's also a poker face. You can never tell what he's thinking. You look at him or he ain't even smiling or nothing. All right. Question 3. Technician A says a 4-wire oxygen sensor contains a heater. Technician B says the PCM sends a voltage to adjust the oxygen sensor voltage signal in order to balance the air-fuel ratio. Who's correct? Question 4. A vehicle emissions test indicates high levels of NOx. The most likely cause of this condition is A, a rich air fuel mixture, B, a clogged catalytic converter, C, a cylinder misfire, or D, a stuck closed EGR valve. Technician A says a stuck open PCV valve will result in oil puddling in the breather. Technician B says the PCV system removes blow-by gases from the engine's crankcase. Who's correct about that? Okay. The cylinder compression test is performed on an 8-cylinder engine, Mr. Engine Repair. These tests with test results indicate what? We've got 149, 92, 94, 150, 149, 150, 148, 148. Is it going to be burned exhaust valve, weak piston rings, a faulty head gasket, or incorrect valve timing? Are you about to go to sleep and turn into a skeleton? Question number 7. A misfire is detected at the number 5 cylinder of a coil plug ignition system. There is no power in the B+ terminal of the coil. Which of the following is the most likely cause of this condition? Resistance in the primary circuit, resistance in the secondary circuit, a leak in the secondary insulation, or an open between the coil and its power source. Now the primary circuit is the trigger that makes the coil fire. The secondary circuit is what makes the spark. Okay? Just so you'll know what the difference between those two are. A vehicle with a 4-cylinder EFI engine has poor acceleration. The live data stream shows the engine has a long-term fuel trim of -19 at idle. Technician A says too much fuel in the air-fuel mixture will damage the substrate of the catalytic converter. Technician B says a long fuel trim of -19 indicates the PCM is adding fuel to the air-fuel mixture. Vehicle's got a fuel trim of -5 at idle and -25 at cruise. Again, tool data indicates a steady oxygen sensor output voltage of 800 millivolts. When a vacuum hose is disconnected from the intake manifold, there is no change in the oxygen sensor voltage. This condition is most likely caused by A, an intake manifold leak, B, a faulty throttle position sensor, C, a faulty oxygen sensor, or D, a kink in the fuel return line. Vehicles emitting black smoke from its tailpipe. And now, which of the following is causing this condition? One of these 4 things is what it's going to be. A leak in fuel injector. B, worn piston rings. C, a blown head gasket. gasket or de-leaking valve stem seals. All right. Who feels like they've been smacked around by this test? Was it hard? All right. Somebody tell me what the primary job of the rear O2 sensor is.
To measure the oxidation impacts of the catalytic converter.
Now, what did you say, Nick?
I was just gonna say, measure the efficiency of the
Catalytic converter. That's right. That's right. So if you put that down, you know, the next time you have to slap yourself, you don't have to. All right. Name the function of 4 wires on a conventional O2 sensor. Y'all forgot that already? 2 wires. There's an oxygen sensor right there. 2 of the wires are white, 1 is gray, 1 is black. What are the 2 white wires? I told you guys this before. That's the heater. Ground and power for the heater, right? You got it? And then you got a ground for the signal. Then you got the signal. So you got a signal reference ground. You got ground for the heater. Then you got the heater power. And then you got what's coming out of the sensor, which is basically going to be your signal that's doing your.
That's what I was thinking, but I didn't know if that was the right answer.
Yeah. Oh yeah. That's basically what I said. I even drew the sensor here for you. Actually, that's from the GM thing. All right. What about this right here? Does the 4-wire oxygen sensor have a heater in it?
Mm-hmm.
It does. You know where the heater is? Right there. It's almost like a glow plug. All right. Technician B said this PCM doesn't send a voltage to adjust the oxygen sensor voltage. It doesn't do that. Now there is, some of the Jeeps will send the voltage down there and it'll be 5 volts until the oxygen sensor heats up and it drops into that range, you know. I mean, but it doesn't actually send the voltage down there. The voltage is created by this. That ceramic zirconia is like an electrolyte. And as the, you know, whenever it's measuring the oxygen that's out, is in the exhaust of what's in the air out here, and it causes electrons to flow back and forth, and that's why it does what it does. All right, this one here is going to be a stuck closed EGR valve. The EGR valve prevents oxides of nitrogen. Some of you guys that are in emissions last time, you remember that? Oxides of nitrogen are prevented by that. How come? It's recirculating the inert exhaust gas. Only like 5% of it goes into the mix, and that makes it run a little cooler. You don't want the burn to go over 2,500 degrees Fahrenheit, because when it does, the oxygen and the nitrogen in there are locked together. The nitrogen's your working fluid. Basically, the burn heats up the nitrogen, and that's what pushes the piston down, right? That's the expansion that happens. Well, if it burns hot enough, that oxygen and nitrogen will get together into all different kind of nitrogen compounds, and it ain't good. So basically, we try to keep from making it. Some of them will actually change the exhaust valve time and close the valves early, leave some exhaust in there so they don't have to recirculate it. That's what Contour started doing back in 1995. And a lot of typically if an engine has got variable valve timing, it doesn't need EGR. That's just basically the long and short of it. Okay, stuck open PCV valve, is that going to get oil puddling in the breather? No, if it's stuck closed it will. Because what it's doing is it's basically pulling air through there and processing it in the engine, right? Well, if this is stuck open, it's going to be pulling a lot of air. If it's stuck closed, yeah, you'll get some oil in the breather. All that. Technician B says the PCV system removes blow-by gases from the crankcase. That's the truth. So B's the one that's right on that one. And cylinder compression test is performed. That's a blown head gasket between them 2 cylinders. What that is. Compression going back and forth. Got that? So that's going to be C. Misfire detected. That's going to be an open between the coil and its power source. It just told you the B plus terminal didn't have any power there, right? That ain't complicated. Everybody should have got that right. Vehicle 4-cylinder DFI engine. Live data stream shows minus 19. If you got too much fuel in the air fuel mixture, you're going to mess this catalytic converter up. That's why it shuts off the injectors when they start skipping a lot of time. B says long fuel show of minus 19. That don't mean it's adding fuel, it means it's taking it away. Minus 19, that ain't hard to remember, right? And so this guy's right, this guy's wrong. That's going to be A there. And